So your department is holding a raffle. They sell 30 tickets and offer 7 prizes. They place the tickets in a hat and draw one for each prize. The tickets are sampled without replacement, so we don't put it back. What is the probability of winning a prize if you buy 1 ticket? So when I think about this, I'm going to ignore the hint for a minute. I'm going to show you what it'd be if you went the long way. You're like, okay, so I want to win a prize. Well, they're doing this 7 times. So I think, okay, they're doing something 7 times. 5, 6, 7. Well, if you want to win on the first draw, you only have your 1 ticket, and there are 30 tickets total. So you'd want to win on the first draw, but then that means the next draw is not going to be your ticket, right? So it would have to be one of those other 29. It'd be one of those other 29 other tickets. And the total, well, they already pulled one out, so it's actually 29 and 29. Which makes sense. You might be saying, well, that's 1, which makes sense because you already won your 1 prize, and now it doesn't really matter. You can't win again. So there's, for every other spot, there's a 100% chance that you're losing because your ticket already came out. So you had your 1 ticket that won out of a total of 30. They drew it out, so there's only 29 left. And all 29 of those will be you don't win. So the first spot has to be you win. But if you're going on the first spot, then that means you have to lose. You have to lose. And etc. All of those are going to be you have to lose. Okay, so the next one you're going to have a 28 out of 28 chance of losing because there are 28 tickets and none of them are yours. And 27 out of 27 and so forth. Which that's some big number, okay? But you don't necessarily win on the first draw. You might win on the second draw. So, I mean, for that, you'd have to lose, then win, then lose. And you have to do that 2, 3, 4, 5, 6, 7 for 7 draws. So first you have to lose. So there are 29 tickets that are not yours out of a total of 30. The next one you want to win, you only have 1 that you can win with, but there are 29 tickets. Then you have to lose again. So far there's been 2 tickets that have been drawn. So there are 28 left. None of them are yours. Yours has already been drawn. So 28 out of 28, 27 out of 27, 26 out of 26, 25 out of 25, and 24 out of 24. I like to draw kind of my little slots. It just reminds me I have 7 things that have to happen. So you have to go through. You have to find the probability of winning on the first draw, plus the probability of winning on the second draw, plus the probability of winning on the next draw, plus the next one, plus the next one, etc. Okay. So after you go through all of those, you'll have to add them all up. All the way up to the probability of winning on the 7th draw. So once you go through, you found the probability of winning on your 7th draw, you have to add them all up. This is going to take way too long. I don't want to write it all out, and I don't want to put it on my calculator. So that's why I had my hint of it becomes like an at least 1 problem. So the probability of winning equals 1 minus the probability of losing, or winning 0 prizes. And so this losing would actually be losing on all 7 draws. That's going to be a lot easier to figure out. So it'll just be 1 minus, so to lose on all 7 draws, the first draw you would have to lose. So there are 29 others to make you lose out of 30. And we're going to have to do this 1, 2, 3, 4, 5, 6, 7 times. And we have to lose on every one. So lose, lose, etc. The next one, there are 28 that are not yours out of 29. And then there are 27 out of 28. Then there are 26 out of 27. And then there are 25 out of 26. And 24 out of 25. And 23 out of 24. Is that a 1, 2, 3, 4, 5, 6, 7? So put all that into your calculator. And if I did it correctly before, it should be about 0.2333. So that's going to be the probability that you win one of the prizes. So again, you could figure it out. You just have to figure out the probability of winning on each prize and then add them all up. But this is a lot easier. Anytime you start looking like this and you're like, oh, I could win on the first one or the second one or the third one, and you have to start figuring out all the different ways you can win or lose or whatever you're talking about, that's when a little bell goes off in my mind that says, try the complement rule. If you're having to figure out lots of different probabilities, try the complement rule.